Okay, welcome to Math 20-3, Chapter 1, Getting Started. Chapter 1 deals with the concept of interest and investing money, and we're going to be learning about simple interest and compound interest. First off, we're going to be doing some review, learning about how to use your calculator, so make sure you have a calculator that has all the functions on it. Don't really need trig functions yet, but if your calculator has trig functions, that's great. That'll come on in later chapters. It has to have a percent sign on it, exponent sign on it, square root, okay, brackets perhaps to make things easier. Basically, a scientific calculator is what you're looking at. All right, so let's go through this. Let's do some simple calculations. This is going to be basically a little bit of review from grade 10, 10-3. Okay, so nothing you haven't seen before. So it says calculate 500 times 0.03, so we can take our calculator, we can clear it, and I'll just move it over here out of the way, and we'll just take 500 and we will multiply it by 0.03, and that equals to 15. Okay, you can do the other three here using your calculator. When you're doing something like this one here, you can do 18.5 times, and then you can do 73 divided by 365. Because of order of operations, your calculator follows BEDMAS. It will do this calculation before it multiplies it by 18.5. Okay, write each percent as a decimal. Now, if you remember from Math 10-3, percent means per 100. So 8% is just the exact same as the fraction 8 over 100. And if you just take your calculator and you just do 8 divided by 100, you're going to get an answer of 0.08. Now, most of you should be able to do this using mental math, okay, knowing that 8 over 100, it's going to be in the two decimal places, okay, the hundredths column, because 8 is in the hundredths column, okay, 12.5%, okay, I'll do this one here, it's the same as 0.125, not 0.125, 125, okay. 73.4% is the same as 0.734. You can also take your calculator to check it. Okay, so you do the last one. Calculate each percent. 1% of. Now remember, when we talked in Math 10-3, the word of means to multiply. So 1% is the same as 0.01 times 1500, which is equal to, well, we can take our calculator for that one. You should be able to do mental math just by moving, because it's 1, moving the decimal point, but let's use our calculator just to be sure. 0.01 times 1500, and we get an answer of 15. Okay, so you do B, C, and D. Tech tip, percent of a number. Calculate 1.5% of 315. If your calculator has a percent key, so I'll look at mine. Let's clear it. And somewhere on here I have a percent key. Okay, my calculator does not have a percent key. It's a little bit too complex for that, but some of the simpler calculators, you'll actually see it has a percent key on there. So if you have a percent key, you can take 315 times 1.5 and then hit the percent, or 315 times 1.5 second function percent. It all depends on where it is on your calculator. Mine doesn't have a percent key on there. Okay. So what I have to do is I have to convert 1.5% to a decimal, basically take 1.5 divided by 100, which is 0.015, and take 315 times 0.015. Okay? All right, so let's go on to the next one. Calculate each percent to one decimal place. So 7% of 2,000, that's the same thing as saying, I'll do the first one, 7% is 7 divided by 1,000. Which is should be 0.007, yeah, and multiply that by 2,000 equals 14. Okay, so you go ahead and do the other three. All right, so now we're going to do a little bit of algebra. Solve for x. So we have 2x equals 12. Well, that basically means 2 times what number equals 12, and if you know your simple times tables, which you should, all the way up to 12 times 12, okay, you know that 2 times 6 equals 12, x is equal to 6. We'll do B, 7x equals 21. 7 times what number equals 21? Well, we know x is equal to 3 because 7 times 3 is 21. Those are fairly simple. This one here, I'm going to show you a quick step for algebra. X subtract 7 equals 32. Well, basically in our mind we just say, okay, well, if I have a number that's 7 larger than 32, that's going to be that number there. But algebraically I can figure it out by adding 7 to both sides. So I could say x minus 7 plus 7, because negative 7 plus positive 7 is 0, so I end up with x all by itself. X plus 0 equals x, is equal to 32, and what I do to one side I must do to the other side. I added 7 to this side, so I'm going to add 7 to that side, and I get x is equal to, because these two cancel themselves out, so I get x is equal to 32 plus 7, which is 39. Okay, so you can do this in your head, but it's also good to know how to do it algebraically, because you're going to need to know how to do this step in some future calculations. Okay, x divided by 5, some number divided by 5 equals 45. Well, how can we figure this out? Well, we can just pretend that 45 is the same as 45 divided by 1. We can write it like that. So what we have is we have an equality here, okay, with a fraction on one side and a fraction on the other. And you have heard of cross multiplication. If I take the top number on this side and multiply it with the bottom number, because we have an equal sign here, it only works when we have an equal sign, multiply it with the bottom number here, that's equal to this bottom number on this side multiplied with the top number on this side. So basically what I have here is I have x times 1, cross multiply, I'm going this way, is equal to 5 times 45, going that way. 5 times 45. Notice I didn't put the time symbol, I just did 5 bracket 45. You can write multiplication that way. Well, we know that x times 1 is x, so x is equal to, and 5 times 45. So we just take our calculator, I'll clear it here, and we do 5 times 45 equals 225. 225. So how can we check that? Well, we know that some number divided by 5 equals 45. So if I was to take that number of 225 divided by 5 in my calculator, would I actually get 45? Okay, that's one way that you can check it. Okay, so solve for each variable. Okay, this is algebra. So what we're going to do is we're going to apply the same principle, the same rule that I used last time. We want to get d all by itself. It's attached with a 4. We'll worry about the 4 later. But I want to solve for d. So how do I do that? I've got to get rid of this 15. So I've got to take it to the other side. How do I do that? Well, I can do it this way. I can say 4d plus 15. Now I want to get d by itself, which means that to get rid of the 15, I have to get 0 somehow. Well, I got positive 15, or plus 15. How do I get 0? Well, if I subtract 15 from this side, plus 15 minus 15 is 0. But what I do to one side of the equal sign, I must do to the other. So I have to subtract 15 from the other side. So I get 295 subtract 15. Okay, 15 minus 15 is 0. So I end up with 4d is equal to 295 subtract 15, which is 280. Now the question is, how do I get rid of that 4? How do I get d is equal to? Well, any number divided by itself is the number 1. And 1 times d is d. So if I divide this by 4, any number on the top has the same value on the bottom, will cancel each other out. So 4 over 4 is the same as 1. 1 times d is d. But what I do to one side of the equal sign, I must do to the other. So I must divide this side by 4. So now I can just say that d is equal to 280 divided by 4, which is equal to 70. And there's my answer. D is equal to 70. So you can bring that answer of d equals 70 back up into here, substitute it in. 4 times 70, okay, is 280 plus 15 equals 295. That's one way that you can check it. Okay, do the same thing with B. I'll do C here. P divided by 3, subtract 15 equals 120. So I need to solve for P. How do I do that? Well, the first thing I need to do is I have to get my variable, again, on one side of the equal sign all by itself, which means I have to get rid of the 15. How do I get rid of the 15? Well, if I have negative 15 or minus 15, if I add 15 to this side, I get a 0. Okay, so let's try that. P over 3 minus 15 plus 15 is equal to 120, but what I do to one side, I have to do the other. So if I added 15 to this side, I have to add 15 to this side. So I end up with P over 3 is equal to, because this negative 15 and positive 15 cancel themselves out to 0, and P over 3 plus 0 is still P over 3, is equal to 120 plus 15, which is equal to 135. Okay, so how do I solve for P? Well, it's same as the question on the previous page. If I equate this over 1, I haven't changed anything. 135 is still the same as 135 divided by 1. I can cross multiply again. I have an equality. This fraction is equal to this fraction. I can cross multiply. So I get P times 1 is P is equal to 3 times 135. 3 times 135. So I just end up with P is equal to 405. Very simple. So you can take that number of P is equal to 405. You can substitute it back in here to check your answer. Sometimes it's always good to check your answer. 405 divided by 3, subtract 15, and see if it equals 120. Okay? You can do D. Substitute and solve. Perimeter equals 2 times the length plus 2 times the width. This sounds like it's for the perimeter of a rectangle. So when it says to substitute and solve, we take the numbers that they have for the variables and substitute them in. So if the perimeter is equal to 2 length plus 2w, and the length is 4, the width is 1.5, so this will be 2 times 4 plus 2 times 1.5. Notice how the brackets just mean to multiply. So 2 times 4 is 8, plus, and 2 times 1.5, or 1.5, is 3. 8 plus 3 is 11, so the perimeter would be 11 if the width was 1.5 and the length was 4. Okay, so you can go ahead and do B. Okay, write each length of time as a fraction of the unit given. Over here, the hint: 1 year is 365 days, 52 weeks, 12 months. And 1 month is 30 days. So let's use this information right here to fill in these blanks. So 3 weeks is equal to how much of a year? Well, it's just 3 out of 52. Okay? B, 7 weeks in terms of years is just 7 out of 52. Okay, 7 weeks out of 52 because there's 52 weeks in a year. 23 days is equal to how much, what fraction in months? Okay, 23 days. So we're talking about 1 month being 30 days. Okay, so it's just 23 out of 30. And that fraction, 23 out of 30, will give us the time in months. 5 months is equal to what over what in terms of years? Okay, well, 1 year, we're talking about months here, and there's 12 months in a year. So it's going to be 5/12 of a year. Okay, that's what 5 months is, 5/12 of a year. Rom decided to put some money in the bank for 1.36 years. Okay, how long is this in days? Round up. Well, we know that there's 365 days in a year, so 1.36 years times 365 days per year gives us a clue as to what units they want, days per year, is about 496 days. Take your calculator and calculate out. You're going to get a decimal, but it just says round up. How long is this in weeks? Round up. Well, 1.36 years. How many weeks are in a year? We know there's 52 weeks in a year. So we're going to get 1.36 times 52, and it's about 71 weeks. Okay? Why are we doing this? Well, that's going to come up in a lesson, future lesson. Okay, in this chapter. Okay, Hank worked in Nunavut as a journeyman welder on a temporary contract. His contract was for 7 months. What is the length of Hank's contract in days? Okay, well, we know there's 30 days in a month. We're talking about 7 months, so we can just take 7 times 30, and that would be 210 days. Okay, we want the answer in days, so 7 times 30 is 210. What is the length of Hank's contract in years? Well, we know what it is in days. We know it's 210 days, and we know there's 365 days in a year. Okay, 7 months is 210 days, so we just take this number divided by this number, and we're going to get an answer, 0.58 years. So almost a little over half a year is 7 months. Okay, so that's getting started, just learning how to use your calculator, getting some basic information in preparation for how to calculate interest. Okay, so that's really important that we also remember how to do some basic algebra right here. Okay, how to solve for a variable. Okay, that's really important too. Okay, that's the end of this lesson. We'll go on to 1.1.